Learning Spark is not about just understanding the APIs and Spark SQL. It is about building applications using Spark. To build applications, we use programming languages like Python. I have seen quite a few big data projects, especially using Spark. Many people try to use Spark for everything. At times, we have to use other set of libraries depending upon our needs. One classic example is nothing but understanding our files. When I say understanding our files, I am talking about paths of the files, the size of the files, and other characteristics. I have seen people struggling using Spark-based APIs to get details about files. However, you should be using the libraries such as dbutils for Databricks, Boto3 for AWS. Like that, each and every cloud platform have their own SDK. Using the SDK, you should be able to come up with code to understand details about your files. Now, let us spend some time in understanding how to use dbutils to get details about files within a Databricks platform. Keep in mind, dbutils stands for Databricks Utils. It is available within Databricks platform only. That being said, we are going to see how dbutils can be used to get details about files. Keep in mind, dbutils have something called as fs. That fs is same as what we have seen using %fs earlier. For each subcommand we have seen under %fs such as ls, head, etc. We have functions within dbutils.fs. You will understand once we get into the details. Here we'll actually review the datasets. Once we understand the datasets, we'll also define the problem statement. The problem statement is about getting the details about file extensions and also file sizes. We'll also see how to write Python code around dbutils to get overall size of the folder. We will actually add sizes of all the files within a folder and compute the total size of the folder. That is what we are going to do to explore dbutils.fs, primarily to understand how to use that package or module to get details about files within Databricks platform. Hello and welcome to this module on file handling in Python. In this lecture, we will introduce the concept of file handling, why it is important, and give an overview of what we will cover in this module. Understanding file handling is crucial for any programmer as it allows you to store and retrieve data from external files, making your programs more flexible and powerful. First, let's see the importance of file handling. File handling is a fundamental skill in programming. It enables you to persist data, share data, also manage large datasets. As part of persisting the data, we store data permanently in files which can be read and processed later. When it comes to sharing the data, we should be able to share data between different programs or systems. When it comes to managing large datasets, we should be able to handle large datasets that cannot be stored in memory. Before getting into the details related to dbutils, welcome to our channel Iterate. In case if you haven't subscribed to our channel yet, make sure to subscribe and also make sure to hit on bell icon so that you are notified whenever we upload the content. At Iterate, we have quite a lot of content on Spark as well as Databricks. In case if you wanted to learn more about Spark or Databricks, you can actually look at the description. There are links to other videos such as developing simple programs like word count, learning PySpark DataFrame APIs, learning Spark SQL, and also building end-to-end pipelines, performance tuning, and many more. Feel free to click on the link based on your preference and continue learning. That being said, now let's get into the details related to how to use dbutils to get details about the files. Primarily, we will be focusing on how to compute the size of the folder using dbutils. On top of dbutils, we'll also be using Python-based code. First, let us recap %fs command. Keep in mind, %fs and dbutils.fs are same. %fs is alias for dbutils. Also, make sure to create a notebook before getting into the details. The notebook should be based on Python. Let me change this to Python. I have given the name as Exploring dbutils for this notebook. Now, to get started with %fs, we just have to say %fs then ls. Then we can specify the path for the folder in DBFS like this. Keep in mind, this is the folder where Databricks actually provide quite a few free datasets. Now let me run this. You should be able to see the outcome in a moment. In case if you wanted to get help on this command, you can just say %fs ls. It will actually show the help. Also, you can actually run just %fs command. It will list all the subcommands that are available within %fs. We will go to the details once this command actually run. Let's wait until this is run, then we will take it forward. Now you see the command ran successfully. you can see quite a few subfolders under Databricks-datasets along with files such as spark readme.md, readme.md, etc. Now I'll be picking a folder called as songs. Let me scroll down. Let's see whether we have folder songs or not. You can see here under Databricks datasets we have a folder by name songs. The folder songs have quite a few files. We'll go to the details very soon. Now let's add one more cell here. Let's say %fs to get help on %fs command. You can see the outcome here. It is actually referring to dbutils.fs. So %fs is nothing but alias to dbutils.fs. You can go through details about this package. Within this package, there are several functions. You can see here under dbutils.fs, we have functions categorized under fsutils, and also there are functions categorized under mount. We don't need to worry too much about these at this juncture. However, we can actually review the functions that are available under fsutils. You can invoke these functions either by using %fs command or by using dbutils.fs, then the function. So in this case, if you wanted to use ls, you can say %fs space ls. In the similar manner, you can also say dbutils, then fs, then ls. Now let's specify the path. The path is nothing but this one. Let me copy, then let me paste, let me run it. You can see the outcome here. However, when it comes to the outcome, it is a bit different to whatever we have seen here. In this case, %fs ls not only get a list of files, it will also beautify and display in the form of table. When we use dbutils.fs.ls, it is just listing the details about the files without beautifying it. Keep in mind, %fs ls and dbutils.fs.ls are same. You can use any of these functions in similar manner. Either you can use %fs or you can say dbutils.fs. If you wanted to use put, you can say %fs put and then pass remaining arguments. Also, you can actually use dbutils.fs.put to actually use put function. Here, I'm not going to cover what put actually do. I'm only covering how we can use put by %fs and also by dbutils.fs. Now let's review what we have in this folder. Let me copy this. Let me scroll down here. The folder which we wanted to review is nothing but songs. We can say songs, then /, then run it. We should be able to see all the files and subfolders if there are any in this folder. You can see these have two subfolders. One is data-001, the other one is data-002. Now let's copy this and then paste here, then say data-001. Let me run this. Let's see what it have. It have quite a few files. The first file is nothing but header.txt. Remaining files start with part hyphen and then there is a number. You can see here. This is the name of the file. It is nothing but part hyphen 5 zeros, then part hyphen 4 zeros 1, so on and so forth. There are quite a few files in this folder. You can see here there are 113 files. Out of these 113 files, one is header.txt, the others are part files. The part files are the ones which actually have the data. Now, take it as an exercise and also review the details with respect to data-002. Even data-002 have quite a few part files and header.txt file. That being said, this is how you should be able to use %fs ls. If you wanted to get same outcome using dbutils.fs.ls, then you should be able to take care of it like this. You can say dbutils.fs.ls, then you can copy paste this path. Let's run this. You can see the outcome. In case if you wanted to get the total number of files that are there in this location, you can use len function. Len is Python's function. Let me say len and then let me paste, then let me run this. Keep in mind dbutils.fs.ls returns list. If you use Python, if it is Scala, it might return Scala array. But as we are using Python, it is Python list. As it is Python list, we can use functions such as len, which can actually give the number of elements in the list. In case if you want to check the type of it, you can also use the type function. It will return list. That being said, this is how you can get started. You can use Python on top of this outcome to do whatever you want. You should not be using Spark-based APIs to extract the information related to the files from the outcome of dbutils.fs.ls. Once again, I'm reiterating, just learning Spark is not good enough to be a data engineer. You have to be very good at Python as well as SQL. In case if you are new and if you are not fairly comfortable with Python or SQL, we have courses around Python and SQL as well. Look at the description. There are links to full videos within YouTube itself. You should be able to learn basics of Python as well as SQL. I have also covered details with respect to Python and SQL from data engineering perspective. Make sure you follow those links and then learn more about Python and SQL. In case if you are struggling with functions like len, when I use terms like list, so and so forth. Now, if you like the content so far, don't forget to like, comment and share with your friends. Also, don't forget to subscribe to our channel and hit the bell icon to get notified whenever we upload the content. Let's get back to our core agenda, which is nothing but exploring dbutils to get size of the folders. In that process, we'll also understand quite a few other important details with respect to dbutils.fs. Under songs, we have two subfolders. One is data-001, the other one is data-002. Each of them have header.txt and also part files. Part files are the ones which actually have the data. Let's understand how to review the data using head. Either you can say %fs head, or you can also say dbutils.fs.head. In this case, I'll be using %fs head to review the data in both header.txt as well as a few part files. We can actually say %fs, then head, then specify the path. The path is nothing but this one. In this case, first I would like to check the content in header.txt. Let's see what we have in header.txt using %fs head. You can see it have schema of the data. It have column names and then data types. You can see here. This is how you should be able to review the content in the files. This will work as long as the files contain text data. However, if the files are Parquet or VARC or any other binary format, then you will not be able to use head like this to preview the data. In this case, looking at the extension, I have assumed this is a text file, and it is correct. This is the text file, and this text file contains column names along with the data types. You can also review the content of one of the part files. Let me copy this here. Now let me say %fs head, then paste, then part-5 zeros. This is the first part file within data-001. Now let me run this. You should be able to see the outcome as soon as this run. Now you can see the outcome. There are multiple records in this file, so this is a text formatted file with data. However, the column values are actually separated by tab character. You can see here there is a tab. It is not space, it is a tab. Tab means multiple spaces. This is how data is formatted when it comes to files such as part-5 zeros, part-00001, so and so forth. To review both header files as well as part files, I have used %fs head command. I can also use dbutils.fs.head, but we typically don't use head by using the function. We'll just use it as a command just to quickly preview the data. Also, if you observe, these files doesn't have header. We don't have the column names in the form of header in each of these files. The column names along with the data types are made available to us using header.txt. This is a very common pattern. Will be provided with the data and schema separately. Files like part files will have the data. Files like header.txt will have the schema. We also need to learn how to apply the schema on top of the data so that we can leverage data frame APIs or Spark SQL to process the data. Let's not get into those details at this time. Let's focus on getting number of part files and also size of part files so that we understand how much data we are dealing with. In this case, we have only handful of files within data-001 and data-002. But when it comes to actual projects, we'll be having thousands to millions of files. Now let's get into details with respect to FileInfo. If you observe, when I say dbutils.fs.ls, it have written the list. Each element in the list is of type FileInfo. You need to understand what this FileInfo is, and also you need to understand how to get path, name, size, etc. Let me scroll towards the end. Now let me say files equal to dbutils.fs.ls. Let me specify the path as dbfs : then Databricks -datasets, then songs. Let me run this. Now when it comes to files, it is of type list. Each element in this files is of type FileInfo. You can actually say file equal to files of 0. Now a variable by name file is created. If I check the type of the file, it is nothing but FileInfo. You can see. If I just say file and run it, this is the representation of file. It is of type FileInfo. It have attributes such as path, name, size, modification time. Now you can say file.path to get the path details. You can see here when I say file.path, it have returned this value. You can see the details here. In the similar fashion, you should be able to get the name by saying file.name. If you want to get the size, you just have to say file.size. This is how you should be able to get details about each and every file that is there as part of the list. Now let's also get into the details about how to filter out those files which we don't want. In this case, I don't want to navigate through readme.md because it is file, it is not a folder. The folders are nothing but data-001 and data-002. Those are the ones which contain data files. The data files are nothing but part files. So here let's also go to the details about how to filter out those entries which are not required from the files. For that purpose, you can use list comprehensions. Let me say files filtered, or let me just say files _. Then in square brackets, you should be able to specify file for file in files. Then you can have if condition. As part of the if condition, you can actually say if file.name starts with, because file.name is of type string, it will contain data like this. In this case, I am saying if file.name starts with, then data, only then I wanted to consider. Otherwise, I wanted to ignore. Now, if I run this, files _ will only have 2 entries. Those 2 entries are nothing but these. Let me say files _ and then run this. It have returned 2 entries. This is the first entry in the list. This is the second entry in the list. These 2 entries are related to the folders. These folders have both header files as well as data files. Data files start with the part. Let's get into the details about how many data files we have, and also we'll get into the details about the overall size of data files. Here we are attempting to compute the overall size of data files in songs folder. It means we'll be considering both data-001 and data-002 subfolders within songs. So far, we have not only gone through the details about dbutils.fs, we have even gone into the details related to FileInfo. Also, we have gone into the details related to how to access attributes of FileInfo. We should be able to use path or name on top of FileInfo object to get those details. To get size, we have to use size. As we are able to discard readme.md and get the subfolders which have actual datasets in songs, now it is time for us to extract the part files which are nothing but data files. After extracting the part files, we'll also go to the details about how to get number of data files and also size of data files. In this case, part files are nothing but data files. Here, if you observe, files _ have 2 elements. Both of them are of type FileInfo. The path contains the directory paths such as data-001 and data-002. Now we have to navigate through this and then take it forward. Again, we have to use dbutils.fs.ls on this, and then we have to process further. So in this case, let me actually say folders equal to, let me run this. Instead of files underscore, I'm going to use folders. Now folders have two entries. Each entry is of type FileInfo. Now I can say for folder in folders. Again, I have to use dbutils. In this case, again, I have to say dbutils.fs.ls folder. The outcome have to be assigned to variable. Let me say FS. FS stands for files. Then we have to navigate through FS and then filter for those which start with part. In this case, I can say for f in FS, if f dot name dot starts with part, then only we wanted to append to another list which contain the entries related to data files. Let me define that new variable here. It is nothing but data underscore files. Here I am initializing it to empty list. Now I should be able to say data underscore files dot append. Here I wanted to keep track of both path of the file as well as size of the file. You can use either dict or tuple. I'll be using tuple. So each element in the list will be of type tuple. The tuple will contain the path as well as the size. The way you can add path is like this. You can say f.path. Then you can say f.size to include size as well. If it runs successfully, the list data underscore files will have details about path as well as size of each and every part file or data file. Now let's run this and see whether it will run successfully or not. If there are any failures, we will troubleshoot and take it forward. Here it have failed in line 3. You can go to the error here. It have failed in line 3. I'm using dbutils.fs.ls on top of folder. When it comes to folder, it is of type FileInfo. However, we have to pass a string with a valid path. If we say folder.path, it will work. Now let me say folder.path here. Now let me run this. This time it should work. You can see it have worked as per the expectations. Now let's review the details about data files. You can see the outcome here. When it comes to data underscore files, it is of type list. Each element in the list is of type tuple. You can pick this one. This is one of the entries in data underscore files. It is of type tuple. The first element in the tuple is nothing but path of the file. The second element is nothing but size of the file. If I add all these sizes, I should be able to get size of songs datasets. If I use len on top of it, I should be able to get number of files. Total we have 212. In data-001, we have 113 files, out of which one is header file and then 112 data files. When it comes to data-002, we have 101 files. One of them is nothing but header file. Rest of them are nothing but data files. So 110 or 112 from data-001 and 100 from data-002. Hence, we should be getting 212 if we use len on top of it. Now, let me say len and then say data underscore files. You can see 212 as outcome. Now, if you want to get total size by using the sizes in these tuples, you should be able to use comprehensions like this. First, using list comprehensions, let's extract all the sizes. Once we get the sizes using list comprehensions, we should be able to use sum. When it comes to list comprehensions, it will return list. We just have to use sum on top of list to get overall size of our dataset. In this case, to start with the list comprehensions, we can specify square brackets. Then we can specify the for loop. Let's say for I in data underscore files. In this case, I is of type tuple because each and every element in data files is of type tuple. Here we should be able to say I of 1. This is the expression using which we can extract the information from the elements in the list. I of 0 will give us the path of each and every part file. I of 1 actually gives the size. So this is how you should be able to create a new list which contain only sizes. You can run this and review the results. the results contain only the sizes. As this is iterable, you should be able to use sum on top of it to get overall size of the dataset. This is the overall size of the dataset. It is in bytes. Let's also convert this to megabytes. To convert this to megabytes, you have to divide this with 1024 times 1024. The first 1024 will give kilobytes. Then again another 1024 gives megabytes. Now let's run this. You can see the outcome. The total size of songs dataset is 125 megabytes. In case if you wanted to round this off to 2 decimals, you can also use round on top of this. The first argument is nothing but expression which have returned decimals. Now we should be able to say comma 2, where 2 is the number of decimals which we wanted to see. It is the second argument. Now if I run it, I should be able to get the overall size in megabytes with 2 decimals. This is how you should be able to use Python on top of the outcome of dbutils.fs.ls to get the details you are looking for. So far, we have not only reviewed the details about dbutils, we have covered quite a few important details such as how to use dbutils.fs.ls to get the number of data files and also the size of data files. Let's also get into details about number of files based on the extension. It is very straightforward. Again, we have to iterate through multiple folders and get the details. Here we just wanted to get those files with .txt as extension. We have only 2. Let's come up with the code. You will understand what I'm talking about here. I'll come up with consolidated code. I'll be copy pasting the code which I have already used. So first let me start with this. Then let me actually use this piece of code to get folders. Now as we will get both the folders which we are interested in, we should be able to navigate through both the folders using this approach. Let me copy. Now let me paste. Here I have to say f.name.ends with, then .txt. We are only looking for those files which have .txt as extension. Then we should be able to use the data files itself to append both path as well as size. In this case, for header files, we typically are not interested in size. However, if you are actually getting the details with respect to data files with .txt or .csv extension, then this approach works. Sometimes we might even want to get the total number of Parquet files and also size of Parquet files which we are supposed to process. When it comes to Parquet files, they will have Parquet as extension. You should be able to use a similar approach to get not only the total number of Parquet files but also size of Parquet files. For header files, this is not that relevant, but with respect to data files, this is highly relevant. Now let me run this. It have ran successfully. Let me say data underscore files and let's see what data files contain. You see it contains details about only header.txt files. This is how you should be able to get the details whatever you are looking for. Before concluding, let's also consolidate the code with respect to getting the total and also size of part files. Then we'll conclude. So in this case, I just have to copy this to get consolidated code. Then have part here. Also, when it comes to the function, it should be starts with. Then after getting all the data files related details in data files, I have to use this logic. This will give us the size of the dataset. I would like to have both number of files and size of files in the form of tuple. Hence, let me enclose this in circular brackets. I wanted to have the number of files as first element in the tuple. Hence, let me say len of data underscore files, then comma, then the logic which actually gives us the size of data files. As we have consolidated the logic, let me actually convert this to a function. Here, the first line will have def, then get dataset details. This is the function name. It takes one parameter, which is nothing but path. Then this entire logic will be body of the function. Finally, it will return tuple. The tuple contain the number of files and also size of files. Also, when this function is invoked, we are supposed to pass path as argument. Here path is hard coded. We need to make sure whatever argument is passed is used when we actually use dbutils.fs.ls. Let me paste. Now let me run this. Now the function is ready. We should be able to say get dataset details, then path. The path is nothing but this one. The path is supposed to be passed as string. Let me specify single quotes and then specify the path. Now let me run this. It have returned a tuple. The tuple contains the number of files with respect to our dataset and also the size of the files. This is how you should be able to use dbutils and Python to understand more about your files rather than using Spark APIs. Keep in mind, dbutils is broader than just dealing with files. dbutils.fs is the module within dbutils which can take care of dealing with files within a Databricks platform. In the similar fashion, all cloud platforms have their own SDKs to deal with characteristics of the files. We should be using Spark primarily to process the data, not to deal with files at a higher level. As we have gained enough knowledge about dbutils, now let's also get into the details about some common bookkeeping tasks which we typically perform using dbutils. Before getting into details about common bookkeeping tasks using dbutils, I would like to hear your feedback. In case if you like the content in this video, don't forget to like, comment and share. Emphasize on whatever you have learned by following this video. Also, if you have any preference, if you want me to cover any particular topic around Spark and Databricks, don't forget to comment. We'll take it up from there and we'll try to publish the content. To get notified whenever the content is published, you just have to subscribe to our channel and then click on notification icon. Whenever we upload the content, it will be there in your mailbox. Also, as part of our channel, there is a lot of content around Spark and Databricks. In case if you want to learn more about Spark or Databricks, look at the description. There are quite a few links to other videos in our channel which cover different topics related to Spark and Databricks. Just click on the link and then take it forward. That being said, at IT University, we also provide guided programs. When it comes to guided programs, on top of self-paced videos like these, you will also get live support in case if you run into any issues. We'll also provide job placement assistance in which we'll actually take care of building your profile and also conducting mock interviews so that you can face interviews with confidence. On top of training, support, job placement assistance, we'll also start referring to our esteemed clients in case if there are any openings. That being said, if you are interested in our guided program, just send an email to support@ituniversity.com. We'll take it from there. So far, we have gone through quite a few important details about using dbutils to understand more about our files. We have gone through details about how to get a number of files in our dataset and also size of files. There are quite a few other bookkeeping tasks which we typically perform using dbutils.fs. Here I'll be talking about two particular scenarios. These are very common scenarios. The first one is nothing but deleting outdated files. The second one is nothing but keeping track of those files which are not compressed so that if at all we wanted to compress, we can compress. Now let's also get into details about how we can use dbutils.fs to delete the files. I'll not be demonstrating with the code, but I'll give you some ideas. Now, many times there might be files which might be outdated and you just wanted to delete. Because the file info also have modification time for each and every file. Using that, we should be able to identify those outdated files. Then dbutils.fs also have function called as rm. Using that rm, once we identify the files that are supposed to be deleted, we should be able to delete. So we can come up with Python-based code on top of dbutils.fs.ls and dbutils.fs.rm to delete all the outdated files. The second scenario is to identify those files which are wasting storage because they are not compressed. So here also, the way I have demonstrated already, you should be able to go through the file system and see what all files are there which are not compressed. There might be files with a .csv extension. They might not be compressed. You can actually see if the file ends with some compression algorithm like gz or zip or snappy. If not, the files are not compressed. you should be able to identify how much storage is being wasted because the files are not compressed. Once you determine the files are not compressed, probably you can use Spark based approach to compress those files, where we'll be using Spark APIs. These are a couple of tasks which comes to my mind when it comes to bookkeeping using dbutils. Make sure you are fairly comfortable with these. It will definitely add value to your project. Also, it might end up adding value to your interview also. As part of this video, we have covered quite a few important details with respect to dbutils from the perspective of dealing with files in Databricks File System. dbutils is SDK within Databricks. Also, we have seen relationship between dbutils.fs and %fs within Databricks. On top of it, we have gone through the details about how to get details with respect to files and folders using dbutils.fs, and also how to code around it to get the details we are looking for. We have taken the examples of getting number of files and also the size of the files. After going through the code examples, we have even spoken about common scenarios which we can think of when it comes to bookkeeping of the files using dbutils.fs. That being said, I hope you enjoyed the content in this video. If yes, don't forget to like, comment and share with your friends. It means a lot for us. On top of it, if you haven't subscribed to our channel yet, don't forget to subscribe and hit on bell icon so that you are notified whenever we publish more content in our channel. That being said, happy coding. We'll catch up in the next video.